Hi everyone, welcome to my video. Today we are going to do the last part of P4 January 2021. Let's get started. Here is problem 9. We got a sketch of part of the curve with these two parametric equations. The finite region is bounded by the curve, the x-axis, and aligned with equation x equals square root 3. The region is rotated through 2 pi radians about the x-axis to form a solid of revolution. In the first part, show that the exact volume of this solid of revolution is given by this term, where p and k are constants to be found. In the second part, we just have to find the exact volume of this solid of revolution. First of all, we are going to start with the formula of the volume of revolution, which is v equals pi integration from a to b of y squared dx. This one is pi. So in this problem, the region starts from 0 to square root 3. So the upper and lower limits are 0 and square root 3. Y is 2 sine 2 theta. Here is y squared dx. And then we simplify this term, which is pi 0 square root 3 4 sine square 2 theta. And you can see that this term is a function of theta. That's why we have to change the x in terms of theta too. So we know that from x equals to tan theta, x equals to tan theta, we can find dx by d theta. So when we differentiate tan, we've got sec squared theta. dx will be sec squared theta d theta. That's a dx in terms of d theta. Now we can just replace dx by sec squared d theta. And then you can see that the upper and lower limits are still not in terms of theta. These are the values of x, not the theta. So we just have to change the upper and lower limits. So from the previous one, we know that x equals to tan theta. So we're going to make theta the subject. Theta will be arctan x. And then we substitute the upper and lower limits into this equation. When x equals to 0, theta will be arctan 0, which is 0. And then when x equals square root 3, theta will be arctan of square root 3, which is pi over 3 radian. Now we've got the new upper and lower limits, so we put it back into the equation. This one will be pi, the integration from 0 to pi over 3, 4 sine squared 2 theta times sec squared theta d theta. So from this one, we know that sine 2 theta equals to 2 sine theta cos theta. That means sine squared 2 theta equals to 4 sine squared theta cos squared theta. So we can just replace this one by this term. So it's going to be 4 times 4 sine squared theta cos squared theta. And you multiply this term, sec squared theta. We know that sec squared theta is 1 over cos squared theta. So we write it down here, 1 over cos squared theta and d theta. Now you can see that these two terms can be cancelled. Here is what we have left. This term and this term, they are constant terms. So we are going to factorize it out. So then we have 16 pi and sine squared theta d theta. We still can't integrate this term. So we have to rearrange it again. From this identity, we have cos 2x equals to 1 minus 2 sine squared x. So we make sine squared x a subject. Sine squared x is 1 minus cos 2x divided by 2. So we substitute this term into here. Sine squared theta is 1 minus cos 2 theta divided by 2 and d theta here. This term is a constant term, so factorize it out to be 8 pi over 3, 1 minus cos 2 theta d theta here. We're almost done here. Just have to change it into this form. So we put 8 pi inside the integration sign. 8 pi times 1 minus cos 2 theta and d theta. And these two terms are constants, so that's the answer. In problem B, we are going to integrate this term. So we factorize 8 pi out, 1 minus cos 2 theta d theta. Now we can integrate this term. The first term will be theta minus sine 2 theta divided by 2. And we put the upper and lower limits here. Then we substitute it. Pi over 3 minus sine 2 pi over 3 divided by 2 minus 0 minus sine 2, 0, which is sine 0. And since sine 0 is 0, so this whole term is gone. We have 8 pi times pi over 3 minus 1/2 sine 2 pi over 3, which is square root 3 over 2. We simplify this term, it will be 8 pi squared over 3 minus 2 square root 3 pi. That's the volume. Here's the last problem. First of all, we are going to make this fraction to a partial fraction form. The partial fraction of this fraction is a over h minus 5 plus b over h plus 3. And now we are going to move these two terms to multiply every single term on the right-hand side. So on the left-hand side, we have 1. This one times this term. First term will be h plus 3 times a plus h minus 5 times b. Now let's eliminate a by setting h to be -3. So the left-hand side we have 1 equals to 0 plus h minus 5, which is -3. So b is -1 over 8. That's for b. Now we can get rid of b in order to solve a by setting h equals to 5, 1 equals to 8 plus 3, a plus 0. That means a is 1 over 8. So the partial fraction form of this fraction is 1 over 8 times h minus 5 minus 1 over 8 times h plus 3. Now let's move to B. The depth of water in a tank in h meters is modeled by this differential equation, where it is the time in days from when the monitoring began. Given that the initial depth of water in the tank was 13 meters, we have to solve this differential equation to show that h can be written in this form. To change from the h by dt to h, we can't just integrate it directly. We just have to rearrange it first. You can see that h is here, and it doesn't belong to the right-hand side, it belongs to the left-hand side, where the h is. So before we integrate, we have to apply separation of variables. So in the first step, we separate the h and dt. We better move the t to the right-hand side. dh equals minus h minus 5 h plus 3 divided by 40 dt. Now we can move h to the left-hand side. It will be 1 over h minus 5 times h plus 3 dh, where the right-hand side is 1 over 40. Now we have separated between h and t, so we can apply the integration sign. This term is a fraction, and we are already find the partial fraction of this fraction. Now we have the partial fractions, so on the right-hand side, we can just integrate it. This one will be 1 over 40 t plus c. Let's integrate the left-hand side. H is just a constant. We are going to focus on this term only. It is 1 over something, so when you integrate 1 over something or 1 over x, it is 1x plus c. We apply this formula. So the first term will be ln h minus 5 divided by 8, and don't forget to differentiate this to h minus 5 minus ln h plus 3 divided by 8 d by dx of h plus 3. And then we differentiate these two terms and simplify. So it will be 1 over 8 ln h minus 5 minus 1 over 8 ln h plus 3 equals minus 1 over 40 times t plus c. We can call this one as a general solution. Next, we have to find the boundary or the initial conditions to substitute into this general solution to find c. From the problem, we know that the initial depth of water in the tank was 13 meters. So this one means at the beginning. That means when t equals to 0, h will be 13. So we can substitute this initial condition into our general solution in order to find the particular solution. We substitute 0 and h equals to 13 in here. So it's 1 over 8 ln, then you can see if h is 13, 13 minus 5 is positive, so we don't have to maintain our absolute value signs anymore. So this one will be ln 8 minus 1 over 8 ln 16 equals to negative 1 over 40 t plus c, and t is 0. That means c is 1 over 8 ln 8 minus 1 over 8 ln 16. Now we can think of this formula. Ln a minus ln b is ln a over b. We still can't use it yet because we have 1 over 8 here. So either you factorize it out or you move it to be an index. Either way is fine. But I'm going to factorize it out. So this one will be ln 8 minus ln 16. Now we can apply this formula. So this one will be, we have ln 1/2. This is c. After we put c back into the general solution, here we have a particular solution. Now we have to rearrange this particular solution in terms of h. First of all, we factorize 1 over 8. So this one will be ln h minus 5 divided by h plus 3. Now we can move 1 over 8 to multiply the right hand side. So it will be negative t over 5 plus ln 1/2. Now we can rearrange the right hand side term into a single term of ln by making this term to be ln e to the power of negative t over 5 plus ln 1/2. And we can use this formula, ln a plus ln b equals to ln ab. You can apply this formula for this one. It will be ln 1/2 e to the power of negative t over 5 equals to ln h minus 5 divided by h plus 3. So now we have 1 on the left and a single 1 on the right hand side. We can conclude that h minus 5 over h plus 3 equals 1/2 e to the power of minus t over 5, like this. And then we rearrange it by moving this term to the right hand side and moving this term to the left hand side. So we can have 2 times h minus 5 equals to e to the power of negative t over 5 times h plus 3. This one will be 2h minus 10 equals h e to the power of negative t over 5 plus 3e to the power of negative t over 5. Now we rearrange h to be on the left hand side. This one will be negative h e over 5 equals to 10 plus e to the power of, now we factorize h times 2 minus e to the power of negative 2 over 5 equals the same thing. So h will be 10 plus e to the power of, we can change this term to be negative 0.2t. 0.2t divided by 2 minus e negative 0.2t. Wait, where's my 3? Oh, okay. 3 is right here and 3 here. Now they look the same, so that's the answer. So here is problem C. We have to find the time taken for the depth of water in the tank to fall to 8 meters. So this is h. That means we have to set h to be 8 and we solve for t. This is 8 equals 10 plus 3, negative 0.2t, divided by this term. Now we can move this whole term to the left hand side. 8 times 2 minus e to the power of negative 0.2t equals 10 plus, and now we expand 8 into these two terms. So this one will be 16 minus 8e to the power of negative 0.2t. 10 plus 3e to the power of negative 0.2t. So we rearrange it. This one will be 6 equals to 8e to the power of negative 0.2t plus 3e to the power of negative 0.2t. This one will be 11e equals to 6. So we can rewrite the right hand side to be 1 over e to the power of 0.2t. This is 6. And we move it to the left hand side. We move 6 down here. E to the power of 0.2t equals 11 over 6. Now we can take 1 on both sides. So 0.2t is ln 11 over 6. So 0.2 is 1 over 5, right? So we move 5 over there. It will be 5 ln 11 over 6. And the unit is in days. Here is part D. According to the model, the depth of water in the tank will eventually fall to k meters. We have to find the value of the constant k. So they said eventually, that means when the time goes by for so many days or something, we can assume that the time approaches infinity. So we can rewrite this one by 10 plus 3 divided by e to the power of 0.2t. And this part is 2 minus 1 over e to the power of 0.2t. We change from negative index to a positive index. As t approaches infinity, you can see that this term is very big, so as this term. When 3 is divided by a very big number, the whole thing tends to go to 0. So we can just assume that this one is 0. Same here. 1 divided by a very big number, so we can just assume that this one is 0. And what do we have here? We just have 10 divided by 2, which is 5. As t approaches infinity, h is 5 meters. So the depth of water will eventually fall to 5 meters. K equals to 5. That's the answer. That's a wrap. Thanks for watching, and see you in the next video. Bye.